Today we're going to talk about factoring quadratics. We're going to factor mostly binomials and trinomials, but I'm going to show you a few other things as well. So first, let's kind of understand what these terms mean. A monomial means that we have just one term. Now, a term is something like 3x squared. So notice there's no addition or subtraction. A binomial would be two terms. That would be something like 3x squared plus 1. So that plus 1 is meaning now we have two terms. A trinomial would have three terms, so that's going to be like 3x squared plus 2x minus 4. That's like your standard equation of a parabola. And then a polynomial is an expression. Okay, now an expression means that there's no equal sign, and it's going to be an expression with more than two terms. Okay, so greatest common factor. The first thing you always do when you're factoring is you always check for that GCF. So you have to look at the 2 or 3 terms that you have, and you have to see what they have in common. So I'm looking at the -2 and the 10, and I'm noticing that they're both even numbers. The biggest number they have in common is 2. Now I'm also going to factor out that negative because we like our leading terms to be positive. So when I take out a -2, now I'm also going to look at the variables, and I'm going to notice I have t squared and t. Well, t squared means that I really have two t's. So I have two t's in my first part of the term and one t in the second. So they each have one t in common. So my GCF would be -2t. So what I would be left with is t minus 5. Now where that comes from is essentially you're dividing. You're doing reverse distribution. So when I take out that -2t from -2t squared, we're left with positive t. Now the sign here changed to a negative because I factored out -2 from the 10. You got to think about if I were to redistribute this, I have to end up with my original problem. So -2t times t is definitely -2t squared, and -2t times -5. The -2 times the -5 is going to bring that back to a positive 10 with the t. So you don't actually have to check that, but I wanted to show you that what you're doing is reverse distribution. All right, so looking at example B, when I'm looking at the 14 and the -35, the largest number they have in common would be a 7. So that's the GCF of the numbers. Then p to the 5th and p cubed means I have 5 p's in the first term and 3 p's in the second. So they have 3 p's in common. So that leaves me with 2p squared, because 7 times 2 would give me the 14, and p cubed times p squared would give me the 5, minus 5. Now I'm not left with any more p's, so it's just a 5. Now this last one, we have 3 terms, and we have 2 variables. So the 18, the -12, and the 24. The largest number they have in common is a 6. M squared, M squared, M squared. So each term has an M squared in it, so I can take out that M squared. And then n to the 4th, n cubed, and n squared. So the largest thing they have in common, every single term has an n squared. So when I take out 6m squared n squared, I'm left with a 3n squared, because 18 divided by 6 is 3. Or if I were to multiply the 6 times the 3, I would get back to that 18. The m squared is gone now. It's out here at the GCF, and I'm left with 2 n's because I've already taken 2 out. Minus 2n, because the 12, when you factor out a 6, you're left with that 2. The m's are gone. I took away 2 from my 3 n's that I had, and then plus 4. The m's and n's are out here in the GCF, and 24 divided by 6 leaves me with 4. Just remember that if you were to redistribute, you'll have to end up back with your original problem. Factoring by grouping is something that you haven't seen before. Factor by grouping has to have 4 terms. So if you're noticing, these are polynomials that have z cubed and y cubed. So these are not quadratics. We're not actually going to do factoring by grouping until the next chapter, but you need to know how to do this in order to factor a trinomial. So factoring by grouping, what you do is you first look for a GCF in the entire problem. So the 2, the 8, the 3, and the 12, they have nothing in common. So you're always checking for GCFs. There is no GCF here. So what I'm going to do is I'm going to group this into 2 separate pieces, and then I'm going to look for GCF in each of those pieces. So 2z cubed minus 8z squared. What they have in common is a 2z squared. And then I would be left with z minus 4. then you always take whatever sign is right here, and that's going to be the same sign. And then I have to look between the 3z minus 12 and see what they have in common. And that would be a 3. And when I factor that out, I'm left with z minus 4. Something very important to take note of is that these parentheses here will always match. If they don't match, then you messed up. So that's kind of a nice way that we can check ourselves. So now what we're going to do is we're going to group together our GCFs. So the 2z squared plus 3. That's going to be one of my factors. And then this one here that I have written twice, I'm going to write that down just one time as z minus 4. Okay, so again, if I were to FOIL these two back together, I'm going to end back up with my original problem. Let's try it again here in B. First thing you do is look for a GCF. There's nothing in common in all four pieces, so we can go ahead and break that up into the two separate groups. So looking at 45y cubed minus 27y squared, they have in common a 9y squared. And we're left with 5y minus 3. Now remember, we're keeping this same sign. And then I'm looking at the 50y and the 30, and I notice that they have a 10 in common. Now what we've really done here, since we have this parentheses, if we really have factored out a negative 10. So since we've factored out a negative 10, this becomes a 5y minus 3. So just stop for a second and think about if we were to redistribute this. Remember, if we were to remultiply this together, we have to get the original problem. Well, if we remultiply that negative 10 times 5y, that's a negative 50y, which is right there. And a negative 10 times the negative 3, that's going to become that positive 30. Okay, so that's why that sign is changing, because we factored out that negative. All right, get rid of that. Now that we've got our GCFs, I'm going to take the two GCFs and write that as one factor, so 9y squared minus 10. And then the other two terms that are the same, remember that those have to match, identical, 5y minus 3, 5y minus 3. And that will be my other factor.